All right. Chapter 3, Section 3, Graphing Systems of Linear Inequalities. All right, very similar to two things, or it is two things we've already done. We've graphed lines. We've solved for systems of equations by graphing. And in Chapter 2, we graphed linear inequalities, so now we're just putting that together. This first problem, both lines are already in slope-intercept form. So that's nice. We don't have to do any extra work. This first line, we have a slope of 4, and we have a y-intercept of -3. All right, so I'm going to go ahead and graph that line. I've got my y-intercept of -3. My slope is 4, so I'm up 4. 1, 2, 3, 4, right 1. Up 4, 1, 2, 3, 4, right 1. And remember that because this is just greater than, we will have a dashed line. So I'm going to go ahead and get this line dashed. It's a bad line. All right. Line's better. And so remember, when we graph linear inequalities, we're going to shade. So there's two options. We can do the origin test. Test the point 0, 0. Plug 0, 0 into that equation. It should be 0 is greater than 4 times 0 minus 3, which is 0 is greater than -3. Since that works, we'll be shading left of that line. Or we can just look at that inequality sign. And because it's greater than, we're going to shade above that line. So for this one, I'm just going to draw arrows to know which direction that I'm shading. The next problem, I'll do it different. Then my next line, or my next linear inequality, my slope is -2. My y-intercept is 0, 3. So I'm going to mark that point at 0, 3. And I'm down to right 1, down to right 1. And I will have a solid line this time because it's greater than or equal to. Oops. Solid line there. And again, I can do the origin test. I can test the point 0, 0, which in this case would give me 0 is greater than or equal to -2 times 0 plus 3, which is 0 is greater than or equal to 3, which is not true. All right, so I tested 0, 0, it wasn't true, so I'm going to shade the other direction. All right, or if you looked at it just from our inequality sign, y is greater than, so we're going to shade above the line. Well, the solution when graphing systems of linear inequalities is the overlapping shaded area. That's a little big. So this area right here where it overlaps is our solution. Okay? All right. Moving on to the next problem. All right. Moving on to the next problem. Again, both my lines are in slope-intercept form, so that is nice. This first line, my slope is -5. My y-intercept is 3. So I'm going to mark my y-intercept, and I'm going to go down 5, right 1. 1, 2, 3, 4, 5. Right 1. And I will have a solid line because it is greater than or equal to. And then this time I'm just going to go with that y is greater than or equal to. So I know I'm going to shade above the line. Feel free to do the origin test. This time, instead of the arrows, I'm going to cross-hatch. Some of y'all like cross-hatching. It can look nice and pretty. All right. My next line is y is greater than or equal to, or no, y is greater than -2. Since it is just greater than, we will have a dashed line. And remember, y is a horizontal line. So I will have a horizontal line going through -2 on the y-axis. And again, because this is greater than, I'm going to shade above the line. So I'm going to cross-hatch this. As you can see, that overlapping shaded area is our solution. All right, the overlapping shaded area right here is our solution. If we plug every point that we plugged in from the overlapping shaded area would make both inequalities true. Okay. All right. Moving on to problem number 3. Problem number 3. Again, our first line is y is less than 3. Y is a horizontal line. So I will have a horizontal dashed line through 3. All right, this time y is less than, I shade below the line. My second line, nice enough, is in slope-intercept form again. As you can see, I'm going with black and gold anchored down. My slope is -1, my y-intercept is 1. Plot my y-intercept. I'm down 1, right 1, down 1, right 1, down 1, right 1. This time I'll have a solid line because it is less than or equal to, less than or equal to. So I have my line. Again, because this is less than, I will shade below my line. so this region, this overlapping shaded area is my solution. Again, every point that falls in this gold region will satisfy both inequalities and make them both true, which is what we are looking for. All right. Last example problem, again, is already in slope-intercept form, which is nice and easy. We're going to go Christmas themed here. First line, we have a slope of 1, y-intercept of -3. One right one, one right one, one right one, and we'll have a solid line. Y is greater than, so I will shade above the line. Cross-hatching. I'm willing to bet more girls cross-hatch than guys. Alright, next line. My slope is -1. And my y-intercept is -1. Plot my y-intercept. My slope is -1, so I'm down 1, right 1. Down 1, right 1. Down 1, right 1. Again, I will have a solid line. Don't like that line. Don't like that line. There you go, that one's better. And again on this line, y is greater than, so we'll shade above the line. Cross-hatching, cross-hatching. Alright, if you are red-green colorblind like me, I am looking at a trippy little picture. But most of y'all are not colorblind, so you can see it well. But again, the overlapping shaded area, or that cross-hatched area, is our solution and will satisfy both inequalities. So, for your homework, just finish the rest of this front page. Don't worry about doing the back page. We'll do the back page in class tomorrow, so I guess if you want to work ahead, you can. Just remember, on these, if you're given standard form, you can go ahead and put it into slope-intercept form to graph, or you can do m equals -a over b and plug 0 in for x to get your y-intercept. Either way you want to do it, doesn't matter to me. Hope you'll have a good Thursday night, or if you're doing this for Monday, you have a good weekend. Thank you very much. Bye.